Okay, so this is a recording for Module 7, number 6. This problem has a lot of parts. I know it can be a little bit confusing, so let's just go step by step through one of them. This isn't going to have the same numbers that your problem will have, so you'll have to go through and do this for your own problem, but hopefully it'll help. So first of all, to figure out if the relationship has some sort of linear relation, you're going to first of all click on the data, and then if you click this little icon, you can open it in StatCrunch. Now to actually make your scatter plot, so there's our data, we're going to click Graph and Scatter Plot, and then you can choose your X variable of age and your Y variable of the HDL cholesterol, and click Compute. And as you can see here, there really isn't a linear pattern. It's pretty scattered. So when I go over here and I take a look at my choices, I can say there does not appear to be a relation. Okay. Again, yours may end up being a linear relation. Mine certainly is not. Now, next thing I want is to determine the least squares regression equation. The thing is about data, even though this doesn't look like a linear relationship, if I tell StatCrunch to give me a linear relationship, it will give it to me. And then we'll know if it's a good fit based on the R correlation. So if I press Stat, and then I go to Regression and Simple Linear, I can then choose my X and Y variables again, and click Compute. And now I have my least squares regression line for the data, and then it actually is written here for you. So they write it out in y equals b plus mx form, and they also have the intercept and the slope here that you can just plug into your equation. And also, if you go over here, you can now see how this line actually fits the data, and you can tell it's really not a good fit. And one of the ways to see that it's not a good fit is your R squared value, or your correlation coefficient. It's really low. It's negative 0.1. And you really want that to be towards -1 or +1 to be a strong correlation, and this is not a strong correlation at all. But we'll still give our answer here. So they want us to round to, let's see, 3 decimal places. So my slope goes in front of x, so it'll be negative 0.096. So negative 0.096. And then my intercept is 49.6566, so I'm going to round that to 57. So 49.657. There we go, 49.657. And press enter. Okay. Are there any outliers? So this is a pretty, scattered data set. There isn't one in particular value that's pulling this line one way or another. So I would say no. Okay. In my case, it says, assuming the residuals are normally distributed, test whether a linear relation exists between age and HDL cholesterol. Now, here's the thing. If a linear relation exists, that means that the slope is something other than 0. So what we do is we set up our hypothesis always when you're testing this. Beta 1, this little weird B-looking thing, is your slope. So we want that H naught beta 1 equals 0 is your null hypothesis, and your alternative hypothesis is that beta 1 is not equal to 0. And that will always be your hypothesis when you're testing a linear relationship. Okay, next thing is to actually use the p-value here. So if I go back to my data set, and let's go back over here, I believe I had already set up let me just press edit here. So if you look, if I don't touch anything, it already sets up the hypothesis test here for the intercept and the slope. So if I just click compute again, and I look at the table where they've put my parameters for the slope, right, this is your p-value. It's already there for you. And I think they wanted us to round to 4 decimal places. Nope, 3. So 3 decimal places for that beta 1, which again is your slope. So the p-value here is 0.653, but I'm rounding that to a 4, so 0.654. Okay. Next, what conclusion can be drawn at the alpha equals 0.01 level of significance? Remember the little rhyme here. If p is low, the null must go. Okay, so if p is lower than alpha, the null is rejected. Okay, so here I have p is greater than alpha, so I'm not going to reject the null hypothesis. So we say do not reject the null hypothesis because the p-value is greater than alpha equals 0.01. Okay, next I have to construct a confidence interval. Now this also not difficult. So we're going to go right back to our data set, and I'm going to click options here and click edit. And instead of running a hypothesis test, I'm going to run a confidence interval. And I think they still wanted 95% confidence for mine. Yes, 95% confidence, and we're going to click compute. Now once we do that, we have, instead of our hypothesis test and our p-value here, we have our lower limits and our upper limits. And remember, you are doing this for slope. So the lower limit here is negative 0.545. I think we're rounding to 3 decimal places. Is it 3? Yes. So negative 0.545 for the lower bound. And then for the upper bound, we have 0.352. So 0.352. And press enter. Okay. Okay, next it says for a 42-year-old male patient who visits the doctor's office, would using the least square regression line obtained in Part B to predict the HDL of this patient be recommended? If the null hypothesis was rejected, that means that this least squares regression line can accurately predict HDL. If it was not rejected, this means that the least cannot accurately predict. So again, we did not reject the null. So I'm going to press continue here. Continue. Okay. And we're going to say no, because the null hypothesis was not rejected. And check the answer. And there we go. Now, a good estimate for the HDL of this patient. So again, the patient itself was 42 years old. So again, I'm going to go back to my data set. And we can go ahead and do a prediction from here. If you press options and edit, I can then go ahead and predict a value. So I'm going to put 42 in for X. And we use 95% confidence and click compute. And now if you look here, see how it says predicted value? The predicted Y is 45.611. So 45.611, but they only want 2 decimal places. So I'll just put 45.61. Oh, wait a second. I did something incorrect. I apologize. So here, since there is not a linear relationship between age and HDL, the best estimator is the mean HDL cholesterol level. Okay, so here I'm not going to use my line in order to go ahead and find that HDL. I'm going to then go ahead and find the mean. So let's see here. So if I press stat and I press calculators and I press, summary stats, and I press column. Okay, yeah, I want to average the HDL cholesterol and I want the mean. Let's click compute here. So let's see, it says 45.29. Let's try that. 45.29. Let's see if that will work. Yay, it likes that. Okay, so don't make my mistake, right? If yours is not a linear relationship, choose the mean. And again, how you do that is go to your summary stats. So let me know if you have any more questions on that. Sorry about the error, but I hope that you can also learn from my mistakes.